Welcome, everyone. Couple of guys I was talking before, they don't know SMPTE, so now you're going to have a very short introduction to SMPTE, and you can become a member or follow our page or become a friend. So there is many options to join our community. And SMPTE is, oops, I think I jumped to, yeah. SMPTE is the Society for Motion Picture and Television Engineers, 110 years to this year, right? So it's 110th anniversary for SMPTE since 1916. And we are a community of volunteers focused on technology and development technology and media, so all kind of media. So join us. We always doing welcome people to contribute and share their passion and their vision. SMPTE is focused on education, on the standards that most of you know, and membership allows you to have access to all the resources, the standards, the trainings, libraries, and attend any SMPTE chapter around the world. There are many. So thank you so much, Roger, Sports and Media, to having us here. Thank you, Adrian and Pierre Fortin, for supporting our community in this session. Thank you again for Spencer, that is our help us with the AV. It has been fantastic. Julie, that helped us to coordinate all these events, all the meeting here, and all the staff from Rogers, the security, all them very kind. And thank you for our people that hands-on this meeting here. So Tony, Roy, Greg, Reed, Alfred, and myself. We sponsors for this night, so we always count with the companies. So if you want to sponsor SMPTE, and we welcome all the companies to come and have space to speak to our audience. We have many channels. We have a boot camp that's coming in May. So Roy is going to explain more about this at the end. And that's our sponsors for tonight. So a few housekeeping for who is not from Rogers. Restrooms for men's is the first door. So you need to go across the first glass door. That's the left. For the ladies, you need to go through the two glasses door, and that's the left as well. So the doors are open, so don't you're not be locked outside. So you can just get there if you need to. So welcome everyone. Presentation today you'll be Adrian, Cosio, Aaron, McNutt, and Claudio that is going to join us from Calgary. The Q&A session will be during the presentation. So if you have questions, raise your hand. Myself or Roy, we're going to get to you with the microphone so you can make your question. Or if you are remotely, type on the Q&A and someone here is going to collect the questions. You're going to read it aloud here. Sorry. At the end, we have a few words from Roy and Tony. Tony is our chair for, he runs the chapter, and Tony is our Canadian governor. And after the meeting, everyone is invited to join us. There is a social, and that to be at the Bishop and Belcher at Bloor Street. Okay. Everybody will come. It's very nice to go to the social. It's a networking opportunity. One of the roles of the SMPTE is really to connect people, so that's important. So everybody here in the industry, we build upon the relationships we have. So always take the opportunity to meet new people. Okay, so today's seminars, Engineering Broadcast, a software-focused strategy using observability, cloud, and modern development. This is an intersection of something our industry has been doing for nearly a century, reinventing itself. Broadcast television began as a marvel of analog engineering. Early systems in the 9th century were defined by physical constraints, vacuum tubes, signal propagation, and spectrum limitations. Everything was hardware, everything was fixed. Then broadcast evolved, and the electronics systems were adopted, always pushing the boundaries, always spearheading the technology. Then came the digital era. Standards evolved, compression technologies matured, and organizations like SMPTE played a critical role in enabling interoperability and organization. We moved from tapes to files, from SD to HD, and eventually to IP-based workflows. But even then, much of the broadcast engineering still revolved around purpose-built systems. Reliable, yes, but often very rigid. Today, we are in the middle of another transformation, arguably the most profound yet. Media is no longer just about signals, it's about software. Infrastructure is becoming virtual. Workflows are moving to the cloud. Systems are not longer monolithic. They are distributed, dynamic, and constantly evolving. And with that shift comes new challenges. How do you maintain reliability in the systems that are no longer physically bounded? How do we troubleshoot workflows that spans regions, services, and vendors? This is where concepts like observability come in. Not just monitoring what to expect, but understand what we didn't anticipate. It's where modern development practices, automation, CI/CD pipelines, microservices, Scrum, begin to reshape how you design and how you operate media systems. In many ways, we are moving from engineering hardware to engineering systems to systems. Tonight's discussion is about that shift. It's about how cloud-native thinking, software-defined infrastructure, and observability are not just IT trends, but essential tools for the future of media and broadcasting. So, as we begin, I invite you to think about that as the next evolution for broadcast and media engineering. So, Adrian, that's the theme for today, topic for today. Engineering broadcast, a software-focused strategy using observability, cloud, and modern development. So Adrian will be our host for the evening, and he's the senior manager for cloud software platforms at Rogers. And we are going to have as well Aaron McNutt, that's the server delivery leader, and Claudio, that's the Oros, that is the AWS architect. So let's give them a warm welcome.
Thank you, everyone, for coming out. And there's so many people here. It's actually pretty crazy. You told me there would only be like 30 people here. So yeah, thank you all for coming out. It's nice to see new friends and old. My name is Adrian Koziel, and I have had many roles in RSM. Currently, I manage cloud observability and software development for our broadcast division. I want to keep it pretty light, so if you have any questions, just raise your hand up. We don't have to wait till the end of the presentation or end of the slide. And Silvino, I guess, if people have questions on the slide, or sorry, they have questions on the stream, then you could just raise your hand up and I'll answer it the best I can. So yeah, today we'll be talking about something called software-defined broadcast. So let's jump into it. Okay, so a little fun right now. So everyone's familiar with disclaimers. So warning: some of this content is about to be very disturbing. Viewer discretion is advised. So why I say this is not the only strategy that Rogers Sports and Media has. There's many different divisions and tech teams. This is just the start of something that we're building around cloud and software. So it's not like, don't think that we're like, okay, we're going to start moving everything to the cloud, production in the cloud. This is the beginning for us. Yeah, so we're going to talk about cloud and software a lot, but when we move things to the cloud and when we innovate with software, we are very specific on why and what we do. So again, don't think that we have massive teams and we're just re-engineering everything. It's very select. It started very small, which I'll talk about the history, but we hope it'll grow. And yeah, I'll be asking some vendors to build things that kind of align with our roadmap. But I'm not promising that's going to be profitable or it's the right thing you do. So take what I'm saying with a grain of salt. Okay, some little table setting. So I'll be talking about our team evolution, how we started with 1 developer and how we have a team of 12 now. Aaron, which is funny because he's the newest member of the infrastructure team. He'll be actually talking about our on-prem network, which is our core because we're a hybrid environment. Then all the way from Calgary, our AWS architect will talk about everything that leaves from on-prem to the cloud, how we use the hybrid environment. And from the DX strategy and some things that we learn along the way deploying cloud in the broadcast space. And I'll finish it off with talking about some of the software that we've written and our observability journey and stack. Okay, so before we get into kind of what my team does, I want to just talk about our organization and how we've evolved from kind of like a single engineering department to multi-specific engineering. So we have 4 teams on the broadcast side. We have distribution engineering, which handles all our 2110 environments, master control, all feeds incoming, outgoing, satellite, fiber, internet, SRT. They also help manage our 2022-7 network. We have our production engineering team, which handles the studios, REMI production, control rooms, venues. Then we have our IT infrastructure team, which you will hear from today, like mentioned, and they'll be talking about some of the core infrastructure that we have, like firewalls, internet, COT switches, networking, PTP, VMware clusters, VPN, golden images. They do the heavy lifting for us, so we get to build some really cool things. So, and then last but not least is my team that manages observability, cloud, and software development. We've actually done quite a bit around, quite a bit with AI now. Brett and I are part of, I guess, the AI committee, we call it, right? He's on the committee. I'm an AI champion. So we represent RSM as best as we can in the AI space. And we've built a couple applications with AI, which I'll briefly talk about. So we've gone through a lot of changes, like I mentioned, from a single engineering team. We've been building this dev team out for about 4 years. But I'm going to talk about how kind of I got here a little bit. I started my second stint at Rogers in 2017. Actually, Frank Bruno's here. He was the one that got me into the industry. So thank you, Frank. I'm still here. At that time, I was helping build the RAMP network, which is our coast-to-coast network, contribution network. And then I just got an urge from management in leadership around 2019 and asked Pierre if I could lead our NMOC team, our 24/7 NOC. And, I guess he was crazy enough to let me do that. Ran that for a couple of years. We had a major reorg where we split ops and eng. So I managed a small system design team. Some of the big project that we did was building out our 2110 content processing, uplifting our SATS department, building out our first deep dive into Azure, building express routes, redoing all the encoding for that. Then a couple of years later, we moved to AWS and did that all over again. And then one day Pierre just called me out of the blue, and he's like, "I don't want you to do anything with hardware anymore. Want you to focus on software." So that's kind of what I did. No, that wasn't supposed to, but it's okay. He started me with one developer. We didn't really have a plan on where we're going to take this, but we kind of knew that cloud and APIs were a big part of the future. If you think about kind of how we build data centers are built with coax and fiber. From a software-defined broadcast system, it's just APIs. So I kind of took it as a challenge and decided yeah, that sounds like fun. So I went into big rabbit hole of learning, did certs in Scrum, AWS, Azure, a little bit of development, a course on APIs, learned about DevOps, CloudOps, just learn as much as I can. So yeah, like I mentioned, we had a single developer with a single application called VOD And what VOD was, or I guess is, we're about to replace it and move everything to Metagenics and for our asset management and STVI for our orchestration. But it's basically our metadata repository. So it has all the assets, metadata, posters, timing information. So it was one single application and one developer that knew Java. Year 2, this application was pre-built, so we were just maintaining it, but it had no pipeline. It had no CI/CD pipeline, no versioning, nothing. So we were able to hire a DevOps engineer to help us maintain that. We were also able to absorb 2 developers from our innovation lab when we had yet another big reorg. We built an application, which I'll talk about, a little later. It's a manual Scuddy insertion app. I'll do a bigger deep dive into that a little later. Then we realized that our UIs are really ugly. So we hired a UX designer, and that was from our developers, not me saying it was very ugly. Our developers said they're not good at UI UX. So we hired an amazing developer from Shopify when they were doing their layoffs, and she's been with us ever since. And hopefully one day I could show you guys. Just amazing, brilliant. Year 3. At this point, I was pretty overwhelmed because I was running the department and I was the Scrum Master, so I did the daily stand-ups and retros. So we were able to hire a product manager to work on the day-to-day stuff, Scrum, ticket creation, and then we had a bunch of app requests. So we built 2 more apps and a bunch of middleware, so we were able to hire 3 more developers. Year 4, we had the discovery deal. So it was very sudden. I think we found out in September, and we launched on January 1st. So the only way that we were able to launch is with cloud. So at that time, we were able to hire an AWS architect, Claudio, who will talk about our accounts very shortly. And at the same time, I was able to hire an SRE, Mike, who's here today. And I promised I wouldn't, make him talk, and I'll keep that promise. So I was able to hire him because I was doing all the SRE stuff as well. So So that's our 4-year journey. I guess I wanted to kind of go over this because it's an oversimplification of how we got here. But I just kind of want to mention, being in the broadcast space, as much as I would love to go to Pierre and say, hey, can we hire 20 people? That's usually not how it works in our environment or, our industry. So it took time to build, this capability. And, year 5, now we're starting to build some really cool things. But yeah, like I mentioned, it takes time. And one thing I want to mention is not a single one of my staff knows anything about broadcast. I mean, now they do, hopefully, a little bit. So with those 12 headcounts, we were able to build kind of two departments. One, a development team, and the other one, a platform team. So one to build products, and the other one to support the business. So, from all the way from app design, from getting an idea to app design to actually building the product, and then from the platform team perspective, being able to monitor that product, building on the pipeline, CI/CD pipelines. We have some things that run on-prem, some things run in the cloud, but running Terraform scripts to process management. And the platform team doesn't just do things for our developers; it does it for the whole business. So for observability, we want to pull as much metrics and logging as we can into our environment. And same thing with cloud ops. Also, it's we have many tenants in our SaaS. We have many SaaS products in our environment, like Imagine, like Metagenics. It's not just to support our dev team. So yeah, we have a small but powerful team, and what's really cool is we can do the whole life cycle of coming up with an idea all the way to launch, right? So from an idea perspective, we're able to build ideas, do storytelling, design perspective. Our UI UX designer builds it in Figma, and we build all the different menus, technical design. From a build perspective, we have 6 amazing full stack developers that can build the code. We have infrastructure that can deploy, in cloud, on-prem with our pipelines. We have monitoring, so if there's something goes wrong with our application, we're able to alert and process. It's when we launch products, it's also, I think, from a technology standpoint, sometimes we forget the process part of designing systems. It's that's not the sexiest or the most fun to do process management, but that's why we hired a process person to help in that, and we're able to launch a product. So that kind of ends for team evolution. I'll stop quickly if there's any questions in the stands. If not, we'll jump over to on-prem infrastructure.
Okay. Yeah, question here, Adrian.
Oh, hi, Adrian.
Hey.
For CI/CD and infrastructure as code,
yep.
What platforms are you using?
Oh, hey, Nick.
Hi.
Hey, it's been a while. I will get to that in a different slide.
Perfect. Yeah. Thank you.
Yeah.
And Adrian, your team supports the streaming solutions and streaming apps for Sportsnet as well?
On the broadcast side, right?
Broadcast side.
I report under Brett Westorp, and there's kind of two sides to the coin. One is creating the content. The other one is all our apps. So we the app team that we have on the broadcast side is really for content creation. There's a whole nother division for Sportsnet Plus, City TV Plus, Discovery Plus.
Gotcha.
Some of it's built in-house. Some of them is built through partners.
Gotcha. And Adrian, maybe just for people interested in maybe expanding their skill set, in terms of core skills you think it's worthwhile developing, what would your advice be in that?
So like I mentioned in the presentation, if you really think of APIs as connective tissue, I would tell everyone to learn APIs. I think that's the first kind of step in figuring out what a software world is and what you're able to do, like what things you're able to create is learn APIs, right? Download Postman and just play around with APIs. It's a simple thing. Of course, cloud certs are good. Like I mentioned, we're not moving everything to the cloud, but there are portions that we will be accelerating. So cloud is a big one. Observability, which I'll go to, is a big one. Pretty much, every position that I've hired for, I'll talk about a little more. But observability is a great industry to get into. Very high paying.
Yeah. Excellent. Thank you.
Yeah. No problem. Okay. So now, take a break from me talking. I'm going to bring up Aaron McNutt, which is, like I said, brave enough to do this, which is amazing. He was the, I'm not sure how many people George has, but he's the newest addition, and surprisingly, he's doing this, which is awesome. But good for you, man. Yeah, come on up.
Adrian, there was one question online.
Oh, okay.
Just regarding the support
Yes.
on your solutions.
Yep.
Who does the support?
Yeah, support. It's an interesting one. We've battled that a lot, right? So for now, any app that we build, my team still supports, right? But it's a great question because that's the thing. That's the difference between buying products from a vendor and building things is you have to maintain it, right? So we've tried to do as much as we can from observability to understand what's going on with your product, right? Because if you don't have any monitoring, how does anyone know it's gonna break, right? So support, my team supports basically. So I try to be fair and do a rotation schedule. We don't have too many products that are on air now. That will probably change in the future, and that's something that we have to work on. But a lot of our products are internal tools to build content, right? So, if it was down for an hour, it's not like it's master control, right? So, but yeah, it's a great question, and we don't fully know. We're learning. This is a new world for us too, and it's a small team.
Excellent, thanks.
Yeah, Aaron, come on up. Oh, well, I actually want to do a quick funny story. So, yeah, when we build apps, we have to do something called CyberStar. And it's funny that even our protocols, like as soon as they see cloud, it's like automatically pen testing, right? But because we have a hybrid environment and because a lot of our apps are on-prem, the work that George and his team, Aaron, do, it's fun to tell them, yeah, go nuts and do a pen test on a local IP, right? So, yeah, it's the things that they do is amazing. They let us build really cool stuff because of they're maintaining the infrastructure. So,
my name's Aaron. I started at RSM working with Brian Leroy there on the distribution engineering team. For those of you who know Brian, he's actually retiring on Tuesday. Maybe a little round of applause. Recently, I joined the media architect team. Our team is responsible for maintaining our 2110 on-prem and cloud infrastructure, as well as our virtualization, Active Directory. We're kind of just a mini IT team for our media domain and our broadcast infrastructure. So we've got network guys, we've got Windows Active Directory guys, firewall guys, and then they call me the wrangler. They're just trying to keep the projects going and keep everyone on track. So we're going to talk a bit about the on-prem side here. So for decades, our industry was built on engineered certainty. In the SDI era, if you had a signal at the source, you had it at the destination. SDI provided robust connectivity, uncompromised quality, and high reliability, all with near zero latency. Essentially, we built our ecosystems like fortresses that remain static, but we're not particularly scalable when compared to 2110. Today, we're pivoting more to a managed uncertainty. In 2110 and the cloud hybrid world, we've traded those dedicated lines for asynchronous packet-switched foundation, which by its very nature is a best practice effort. It doesn't inherently care if a packet in a frame is part of a Stanley Cup final or a spring training Blue Jay game. It's just a packet. So there's a re-engineering challenge, which is we can no longer rely on the physical medium to guarantee our success. It's not plug and play like SDI. Instead, we use software intelligence to try and impose some order on the chaos. Our goal as architects is to stop fighting the inherent uncertainty of the network and start managing it through more of a deterministic orchestration, real-time observability, and automated path validation. We're not just moving video and audio anymore, right? We're managing a much more complex living software ecosystem where certainty is something that we actually have to calculate and plan for, not something that you just plug into. The architectural pivot. So the pivot delivers 5 core advantages to our infrastructure. First, we are future-proofed by decoupling our media logic from the underlying hardware. We ensure that a shift in resolution or codec doesn't require a forklift upgrade of our switches. We gain agile operations. So because our workflows are software defined, we can deploy a new service in minutes rather than planning a major upgrade, which could take months. So our scalability is now a lot more elastic. We can seamlessly handle the massive bandwidth demands of modern day 4K HDR, 1080p, etc., by just spinning up more virtualized capacity. We achieve a new level of resilience. We've replaced manual pull-the-cable hardware failover with automated software recovery that we can reroute a national feed before an operator even notices a glitch. The hitless, seamless side of things. And finally, we come to cost efficiency, where we're shifting away from massive idle, just-in-case capital investments towards a more optimized consumption model, where our infrastructure scales exactly to the needs of the current production demands. So to deliver on those 5 pillars, specifically scalability and resilience, we have to look at the physics of how we move media. In a modern operation, we essentially have 2 competing philosophies. The first, receiver-driven, or the pull model. This is a traditional IT networking. How it works is through standard IGMP joins and PIM routing. A sender registers itself to a controller, then when a receiver wants to stream, it will make a request to the controller for the multicast information, and then it simply asks the network to deliver it. The switches figure it out how to get it there. So the advantage here is that it's really fantastic for scaling and for decentralized environments. Any device can tune in to any source without needing a central brain to coordinate all the moves. So with that, though, there's a challenge, which is this model is essentially bandwidth blind. The network will keep fulfilling pull requests until a trunk hits 101% capacity, at which point the whole fabric congests and you lose your streams. The link will fail. In broadcast, obviously, that could be quite problematic. We recognize this as a technical reality that's got to be managed. We have this model in place, but we protect the fabric by over-provisioning these specific paths and keeping a high level of observability to ensure that a blind join doesn't become like a major broadcast impacting event. The second is the controller-driven model. So to solve the risk of the bandwidth blind network, we move to the controller-driven or the push model. This is the heart of software-defined strategies. The workflow here is fundamentally different. The controller acts as the intent engine, taking the user's request, passing it on to the media control service, which is known as MCS, which serves as a universal map. The MCS performs a real-time graph calculation of the entire fabric, checking every hop, every inter-switch link, every bit of available bandwidth to guarantee the path. Once the path is validated and reserved, the MCS doesn't wait for the network to figure it out. It uses its high-speed JSON RPC to talk directly to the switches, programming the TCAM hardware tables on every switch along the path simultaneously. By the time the source starts sending, the entire network is already primed and ready. So the primary advantage here is guaranteed bandwidth because the controller knows exactly. Let me move this up here. So the controller knows exact utilization of every 100 gig, 400 gig links in the fabric, and it will perform what we call admission control. If a required 4K HDR stream, for example, would push a trunk to 101% capacity, the software denies the switch before it ever happens, thus you don't overload. We protect the purity of the existing on-air signals by preventing oversubscription algorithmically. The benefit is that this precisely mimics the certainty that we loved about the SDI router, but it does so on a highly flexible and a much more scalable IP fabric. This is our best use case for primary production and core routing, anywhere that ultra-low latency and zero-fail delivery are absolute requirements. So to re-engineer the broadcast environment, we have to move away from thinking about physical lines and starting to think about functional layers. So the first, at the top, we have the orchestration layer. This is where the human or the automation lives, the operator. For example, hits a button for camera 1, or hits a button, take this source, route it to this destination. They're expressing intent. They don't care about the IP addresses. They're not thinking about which VLAN is this route being made on. They only care about the logical connection between a source and a destination. The intent is passed via API to the control layer, powered by the media control service, which we talked about in the previous slide, the MCS. It maintains a full topological map of the entire fabric. Before a single packet moves, the MCS performs a guaranteed bandwidth check. For a 4K HDR flow, it calculates the path and ensures that a 12 gigabit payload won't oversubscribe a trunk. If the path is clear, it reserves that capacity. The MCS then pushes that instruction down to the fabric layer. Unlike traditional IT networking, where a switch waits for an IGMP pull from a device, our SDN pushes the flow directly into the switch hardware. So we are pre-programming the hardware tables to ensure a predictable path for every stream. And finally, the presentation layer. The endpoint receives a perfectly timed, synchronous SMPTE 2110 essence by decoupling the intent at the top from the physics at the bottom. We've created a system now that is agile enough for the cloud, but reliable for live sports in our case. The bigger picture. Now we have a 2110 core. This is our high fidelity island here. Within these walls, we have zero latency. So you have your uncompressed video and audio. It's basically a perfectly managed, reliable network. But a national broadcaster can't exist on just an island, right? There's obviously a lot more complexities. As we zoom out to the national scale, we encounter our translation ring. This is the border control of our network. It handles 3 critical functions. The first being IP address natting. This allows us to ingest feeds from across the country, from Calgary or Vancouver, let's say, without worrying about the local IP or multicast IP conflicts. Essentially, once it's on our side, it's following our multicast tables. So we normalize the national address space before it even touches our core. Protocol translation, this bridges the gap between our synchronous internal fabric and the asynchronous world outside. Which leads us to transcoding. This is where we utilize codecs for production and distribution. The third layer out represents our transport matrix and ecosystem. Here we leverage specific protocols for specific missions. JPEG XS, for example, for our ultra-low latency national backhaul, SRT for our resilient internet-safe links to the public cloud and our DR sites, and NDI HLS for our digital inlets. This is our universal interface for live ingest. Partner resource sharing and final delivery to CDN and BDUs. So by using this layered approach, we protect the purity of our 2110 core while maintaining the agility to talk to any partner in any format, anywhere in the nation.
Aaron, may I ask a question there? It's me.
Hello. Sure.
So everything outside of your 2110 core on that diagram is unicast? Everything within the 2110 is multicast?
Within multicast. Bit of a complicated question, yeah.
Oh, yeah, okay. Generally, yes? Everything outside is unicast? Generally?
Yeah.
Kind of?
Kind
All
of.
right, okay.
Where are we here? So network and scale. Now that we've seen the logical layers, let's look at the network fabric that makes this possible. We utilize a standard leaf spine architecture for our local production islands. This gives us predictable non-blocking performance. The leaves handle our 2110 endpoints, while the spines provide the high-speed backbone for our routing. Then we do the same for the other locations or projects. We connect all these different islands together using a super spine. This architecture gives us the infinite scale we need for now and for the future. We can simply add more leaves to a site or more sites to the super spine without ever re-architecting the core. We also duplicate the same structure to our disaster recovery site. We don't treat DR as an afterthought or give it its own special network. We extend our media and our control plane directly to it. This ensures that in a failover scenario, we still see the DR resources as part of the same unified topology. Then we connect the DR data center with the OMP via dedicated data center interconnects, DCIs. This isn't just a standard network link, it's a high bandwidth, ultra low latency extension of our spine and leaf fabric that stretches across geographic distances. By leveraging the DCI, we can stretch our layer 2 VLANs to our disaster recovery site, which allows us to maintain the same infrastructure regardless of where the infrastructure is physically located. Finally, we extend the same logic to the AWS cloud. The cloud. By treating the cloud as just another site on our superspine, we've created a truly hybrid environment where our media flows seamlessly from the local studio to the national mesh into the cloud. We utilize 2 geographically diverse AWS Direct Connect locations to ensure that no single fiber cut or provider outage can isolate our facilities. Each of our primary sites, Toronto and Montreal, maintain independent paths into these locations. At the heart of this is the AWS Direct Connect Gateway. This allows us to bridge our on-prem BGP routing with our cloud-native infrastructure in a unified way. So from the gateway, we can route traffic into our production and dev VPCs for data processing or directly to Amazon S3 for high-speed file ingest and archive. This isn't just a backup path, it's an active extension of our media fabric. Whether we're pushing a compressed stream for cloud transcoding or pulling historical assets from an AWS S3 bucket, the connection ensures that the cloud feels like a local resource with predictable broadcast-grade latency. So to wrap up, the shift we've discussed isn't just about replacing a BNC connector with an SFP. It's a fundamental re-engineering of how we think about scale and think about resilience. We've moved from a world of static, hardware-defined islands to a unified media fabric. By using a software-defined control stack, we've decoupled our broadcast intent from the physical constraints of the network. The architecture gives us the scalability really to handle 4K HDR today and whatever comes next tomorrow. So it provides the observability we need to manage complex hybrid paths with the same confidence we once had in the simple SDI cable. Ultimately, a software-focused strategy allows us to be agile where we need to be in the cloud and for our digital platforms while maintaining reliability. If we do have more high-level questions, we do have members of our network team here who would be more than happy to answer those as well.
I might have something more of a side level question here.
Sure.
You know, as part of a major IT infrastructure company, it's interesting that you outsourced to AWS. What were the advantages over hosting within your own infrastructure to go and do that?
I think a lot of that is probably driven by costs as well. Things that are a bit above my pay grade.
I wasn't
honestly.
expecting such a straightforward answer, but thank you.
And Aaron, there was one more question from the chat. Is all of your archive in the cloud?
No, it does not. Currently, we have most of it on disk and tape, but certainly we're thinking about other options for the future, depending on costs, just like everyone's kind of dealing with, right? Doing the math and seeing what makes sense going forward. But for now, we keep everything local here, including the disaster recovery, which we have on another site. Yeah.
Gotcha. Thank you.
Yes, sir.
As you move content across the national backbone, the superspine, is the transformation of content invisible to the intent or to the user? Is it automatically done for them, or is it more of a scheduled special function to move content nationwide or up down from the cloud?
George?
This is George.
George needs a mic. Hello, everyone. My name is George. I was told that I would not be speaking tonight. And obviously someone lied. So we'll deal with that internally.
George got the biggest laugh of the meeting.
So what was the question? No, sorry.
So as you move content from site to site through the national backbone, is a transformation of media transparent or invisible to the user that's asking for that? Is it automatically transformed or managed, or is it something that's more explicitly scheduled?
Currently it's scheduled. We're not at that point where we can just send terabytes of data across the country without being completely oblivious to the underlying network, the overlay or the underlay, or even the people that are waiting to receive it. However, the pieces are in place to make this completely transparent. The problem we have now is geography more than anything else. It's having a data center in the west side or somewhere closer to where those people are requesting it. So we have touch points so we can extend that super spine across the country. Right now, we just treat them as one-offs, and it's somebody that's basically reaching into our network here to pull content.
Just the same as AWS as well.
Correct. Yeah, and to be perfectly blunt, we're strongly looking at moving our entire archive into AWS.
Okay.
Maintaining LTO, I have my personal opinion about this. I think the day of the LTO is long gone. Mm-hmm. I think the LTO consortium has lost their way many years ago, and I've been seriously looking at doing it, and we'll probably pull the trigger at that later this year.
Mm-hmm. So things like egress cost or egress charges are not in the equation, or they're just in the noise?
They are, again, if you implement a hybrid model where you can keep the last 2 years of your most newest content on-prem, and take that tape that somebody recalls once every 5 years for a 30-second clip and put it somewhere in the cloud so you can tell your bean counters that, yeah, we do have this content, we still own it, and it's still available, then I'm perfectly happy letting someone else manage that than having to stand up the infrastructure, the power, the cooling. At the end of the day, it's I think it's actually going to end up being cheaper to manage that in AWS with the egress costs. Any other questions since I have the mic and since Aaron sold me out? Nope. All right.
You guys are great at answering questions like totally honestly and sharing information. This is great.
Oh, you know, that's dangerous. Can I quickly ask why were you guys going to use why you didn't use NMOS for orchestration? Are you doing something else, or are you using NMOS?
We have a bit of everything actually going on right now. We're using some IGMP pip. We have some orchestration with NMOS, and now we're progressing more towards the MCS. There's a lot going on here, and we have environments like production. We have the distribution side. We have our city news, so a lot of localized areas in the company that are using different orchestrations. But the plan right now is to move more towards the centralized MCS, which seems to be the future.
And Aaron, I did see CDI on one of your slides, right? Or real-time transport in the cloud, is that right? Yeah? Okay. That was not an open and honest answer. I'm sorry about that question. Anyone else? No more questions. Thank you, Aaron. That was great. Oh, 1 second. While I stepped away, right here, there's a few more questions, or at least one. If you move archive to AWS, how is sovereignty managed? Data sovereignty.
Yeah, so there's two things, I guess. There's actually where is the data center, but we deploy everything in Canada Central, so CA Central 1. So I don't think that it would leave Canada per se. Yeah. It's by, I guess you could call it's an American company, so there's a little bit of that. But yeah, from a physical perspective, AWS is very good that it will stay in Canada, right?
Yeah.
Just to answer some of the questions around why move to the cloud when we have data centers, even like it's almost the standardization too. So we have our Vado MAM system, and they prefer us to move to the cloud because you have so many things on-prem, different versions of Postgres, you have different VMware clusters, where AWS is really it's a standardization basically of, we'll use this database, use RDS. We don't have database admins at Rogers, so managing databases have been a pain. So RDS is kind of like an amazing thing for us, where we don't have to tune databases. So that's one reason why move to the cloud. And another reason is just having your content always available. There's so many things you could do around that with AI, tagging, metadata. Some of the projects that we're working on already utilize it. So right now, only our discovery content is in the cloud, but we do have plans, and the hope is that we move all our archive to the cloud. And as George mentioned, I won't make him talk again, but we want to have object storage on-prem, to have like petabytes on-prem, and then anything that's not available in on-prem is available in the cloud. But because they're both object storage and our direct connects, hopefully we'll bump up to 100 gigs at that time. Right now we're only at 10. But it's why hybrid environments are amazing. It acts as one network. Like I mentioned, we don't think of cloud as cloud. We think of it as an extension of on-prem. Okay, so Aaron did a great job talking about our on-prem networking. So now we want to talk about cloud. His last slide was about our direct connect. So now it's from our direct connects on. So we're going to get Claudio. from Calgary to talk about that. Claudiu started with us about a year ago. He worked in a Rogers corporate, Rogers proper, as an AWS architect, and mostly working a lot of stuff with Rogers Bank. But I guess he wanted to be more hands-on keyboard, so I don't think he's bored here anymore. I hope not. At least he's not bored. I think he's having a good time touching all the things he wants in AWS.
Thank you, Adrian.
Yep.
Thanks for the introduction. Hello, everybody. Hello from Calgary, Alberta. I work out of the Calgary office, and as Adrian said, I'm the newest member of the team, or I think one of the newest. I'm new to media. I've been working all my life in IT, working for starting off with containerization, virtualization, server storage, backups, went through all of it, and then moved to the cloud as of a few years ago, and did a bit of Azure and for the corporate side of things, and Amazon as well. And yeah, about more than a year ago, I had the chance to get on board the hey, we have this project we need to get deliver in a few months. Do you want to do it? And very excited and very happy to be a part of it. Thank you, Adrian, and the media team for having me. Yeah, let's. I want to talk about a little bit about the Amazon. Very general terms, as I don't know if you're using cloud, if you're not using cloud, what is cloud? What did cloud do for us, and would we recommend to use it? Would we keep using it? Recommend it? Would we advise anyone to use it? And what did it do? Again, was it worth it? Basically. So very high level. Hopefully, it's it's a subject of interest, and if you use the cloud, you're going to be aware of most of these things. So why cloud? And I think this is going to address a question I heard earlier. So why keep it on-prem? So if you keep it on-prem in nowadays, in my view at least, you're limiting to a certain. It's all use case, obviously, but you lose the advantage of delivering or focusing on your applications more than building the core infrastructure. So in the cloud, you don't have to worry about, hey, do I have to install Postgres? Do I have to make it redundant? Do I have to build VLANs? Do I have to do this? How do I build that? How do I manage the VLANs? You consider those things as managed services and you move them to the cloud, and now you have to worry about your application. How do I build my application redundant? How do I make it not fail? How do I make it scale? How do I keep it alive? Basically, I move it on somebody else's computer, but that is now still my problem. How do I make my application work? You have infinite capacity. Well, infinite is literally infinite as long as you pay for it, which makes you think now, well, I have to be aware of the costs. How do I forecast? How do I keep track of the costs? How do I pay for it? Is it worth it? Am I using too much? In my compute virtualization days, everybody wanted 8, 16 gig of RAM, 32 gig of RAM. Let's have it, right? Because it's free for somebody that's requesting it. In the cloud, it's not the same, right? You pay for it, and it makes you be aware of all these, be more cost conscious and design for performance in the same time, right? And you have better integration options because you now leverage, you have a focus on the application and services. And Adrian was saying earlier, APIs. What's API? Well, exposing your service in a simple way that can be consumed by anything, anywhere, right? How do you consume it? Well, standardize it. Have a JSON payload, send a call, receive an answer. Is it good? Is it not? Send a message. You decouple your services so you don't set and forget. There's a component that essentially going to talk to another component through a third-party mechanism and be able to negotiate failure a lot better than just closely coupled. And then global reach, right? And in the cloud, you can build a resource in Canada Central today. You can build one in the US tomorrow, or in Asia or Europe. Your options are open to broadcast, to send your data using Amazon's backbone, essentially, leverage their capabilities, which are quite impressive as being Amazon. In our case, Amazon, but it could be any of the other cloud providers. And then do it quick. I think agility is something that you quite get used to when get on the cloud. Yes, you can move fast if you follow some rules. And then we're gonna deep dive a little bit on those, what the rules are, because it could be dangerous and costly as well. So when you experiment, it opens up your options, but you have to do it with a strategy as opposed to do it in a as some of us did it on-prem, hands-on directly at the keyboard versus doing it in code through a pipeline, through an automation pipeline. Next slide, please. And how did we do it? So a year or more ago, we treated the cloud as an extension to the on-prem, like we heard earlier. We did not consider throwing things in there, re-platforming things. It's more of an incremental modernization effort, right? So is this use case worth for the cloud? Is it good? Well, let's see if we can fit it. Now, in order for us to do anything in the cloud, we have to lay out the foundation. So the first thing, we work together with our networks team, with the development team. Within Adrian's team, we are a very integrated team, which helps us move fast. And the communication is really, really good, as opposed to being a silo. So we're lucky that way. We have worked on laying the ground, connecting the networks, and you've seen a slide on earlier. So we have a direct connect from Amazon. We've done a direct connect with multiple providers that are giving us a direct connection in the cloud, which offers us guaranteed speeds and lower cost for egress, lower than if you would do it through the internet. They're like 5 times difference in price. We had to set up an identity and shared access model. So how do we access it? Who do we allow accessing to? What do we allow access to, and so on? And then not lastly, how do we track the costs? We have to label everything. This is something that the on-prem world we haven't had an issue with, but in the cloud, everything has to be tagged, everything has to be monitored, and as far as costs and so on. And then at the end, all of these required process changes internally for everyone. So adopt new security practices. Before we had firewalls on-prem, we had rules open, allow this from here to there. In the cloud, it doesn't work the same, and we're going to deep dive in that a little bit. We have to be cost aware, like I mentioned earlier. So don't just the sprawl is dangerous because it can be costly. So being very cost conscious is critical. And then adopt a design framework that will allow us to scale, to be resilient, to think and plan for failure, because everything fails all the time, as the Amazon CTO says. So you have to be aware of that and plan for it. Again, how do we deploy? How do we maintain? Again, it changes because now you're working in somebody else's data center and you're connecting remotely. You have limited ways of doing things and using their tools and their ways of supporting it. So a lot of it, the deployment and operations, day two ops relies on automation. And we use Terraform as a standard. And yeah, we're going to evaluate what else can fit in the cloud and what is it's worth being refactored, replatformed into the cloud. And the key of it all, and at the bottom of it all, is no disruption, right? The foundation of all of it is maintained services, and everything that happens has to be non-disruptive. And if you plan for failure going forward in the cloud, this should be doable. I mean, literally, through this should be a no-brainer. Next slide, please. So as far as the principles and how are the rules we're trying to follow on the cloud. So again, cloud and premises, there's one platform. Communication flows back and forth. We have to secure both. We build for scale. We try to be elastic. We treat what we build as replaceable. Right? Everything is in code, everything's in the pipeline. Our data should live somewhere else. So a database will generally be put on a managed service where Amazon takes care of it and lives on a storage that has 11 nines of durability. If we need to rebuild our database cluster, we can rebuild it in minutes and we can import that database. And we do database backups. We do everything else using policies as opposed to installing software and having to manage it ourselves. We have to remain cost effective. All these services have a price. So we do a estimate. We figure out an estimate, cost estimate before we adopt anything, and then we stick with it, and we take advantage of the cost discounts that Amazon has for long-running instances. For example, reserved instances is a great discount mechanism that Amazon offers. On the Amazon Direct Connect, like I said earlier, the costs are a fifth less, like 5 times less than if you would do it through the internet. Ingress are free for now, at least. They have been free for forever because. And then yeah, automation. Automation is key. I couldn't never underline more that there would be impossible to build resources, applications in Amazon or in any cloud provider without automation. Last but not least is security. So security is now somewhere else. How do we secure it? So beside the usual network level that we did, all of us did on-prem, so firewalls everywhere and network level, protecting source destination ports and so on. Now we focus more on identity because every resource we have in the cloud has an identity. Think of it as a service account of some sort. So it doesn't matter what it is. It's an EC2 instance, compute instance. It's a container. Everything has an identity. The bucket itself, the storage bucket, the backup, the database cluster, the database instances. And when we say, I want zero trust, that is literally, we don't allow in a database to talk to an EC2 instance or vice versa unless we allow it. So everything is limited both at the network level. We microsegment these things at the network layer using what Amazon calls security groups, which is a network microsegmentation mechanism which does point-to-point manage packet filtering essentially. But we do it from a security boundary, because if a compute instance has an identity, we can say this identity, this compute instance can do database queries on this instance. And of course, it has to have network access to do it too. So multiple layers, defense in depth is what this is used to call. There's never a single layer of defense. We assume that the hacker is already in. Now, how do we limit their presence? How do we limit what they can do? So this is something that we take very, very seriously, and anyone in the cloud should take it, because it's the right thing to do to mitigate business risk and protect the business and the data at all costs, right? Of course, list privilege that comes as part of this. I mentioned earlier, if a machine if an EC2 instance needs to query data in the database, that's all you allow it to do. That's it. Next slide, please. Major thing that we do in the cloud as a standard pattern is use leverage managed services. So managed services, you've heard about Amazon S3, Elastic Compute Service. These are all managed services, right? So we need a database, we build a cluster, and then on top of it, we create a database, and then we start using it all within 10 minutes. Amazon takes care of running the backend infrastructure. All we have to do is just specify, I want this much redundancy, I want this many replicas, I want the backup or not, I want monitoring or not, and so on. Amazon does the background of all these services, installs these under the covers, and we focus on applications. We focus on our service. We focus on building the application service, not on the routine core infrastructure apart. Serverless, right? Lambda, you may have used Lambda. So functions as a service, you need to execute some API call that some processes, some scheduling, for example, from MediaGenX, as Adrian mentioned. You run that in a Lambda. It's a perfect use case scenario. It's a piece of code that runs for up to 15 minutes. It gets triggered by something, and then it ends within these 15 minutes. You pay by the second, and then it will start again whenever the time comes and the next trigger comes. So there's nothing to install, nothing to run other than the code that we have to put there, and permissions, of course, everything with permissions and network access as well. All that reduces the operational overhead and moves these efforts onto more of a high-level architecture design, functionality, resiliency focus in application development, as opposed to infrastructure build. How do we do this? Again, there's so many components to build when in our application, on any cloud application, it requires code. And without code, we wouldn't be able to do it. It's all declarative, so we build it in Terraform, we version it, and we can redeploy it somewhere else. I mentioned APIs, so APIs are great. They allow us, they allow anyone, any application, any microservices, or well, services, microservices, any service decoupling and offer that layer, that connectivity layer in between services, so they're scalable. And this again is a perfect use case for the cloud, because in the cloud you have a managed service that hosts these for you. So all you have to do is just design them and then design the backend. And they're built resilience, and they can be private, they can be public. It's very easy to build upon. In the cloud, and we will also get their observability tools, which are a complete set of metrics, logging, querying mechanisms, auditing trails, and archival to manage all of this. Next, please. Now, as far as the connectivity, I think we saw a little bit on the previous slide from Aaron. We have a direct connection. So at the bottom, we have the direct connects. There's two providers and two separate physical offices, all connected centrally through a logical device in Amazon called Direct Connect Gateway, which allows us access into multiple accounts that we use. So up at the top, we've segregated the environment in production, non-production type of environments. They're all separate. They have their own networks, their own resources, their own purpose, their own access requirements, and so on. But they're all connected centrally through that Direct Connect Gateway to each one of the two sites below. We can always expand these connections. We can add more providers, we can add more locations, we can allow access between these locations if it was the case. The data ingest into Amazon is, there are no charges. The data egress is charged from Amazon. And then the cost for this structure is predictable because there is a port hour. So beside the actual data transfer, there is a port hour which gives you the guaranteed bandwidth of either 1 or 10 or 100 gig. At least we use 10 gig at the moment. And then this connection being dedicated, it's secure and only accessible for the sites and the peers that you see in this picture. From a management perspective, real quick, so we have an organization level single sign-on, which means our access into the cloud resources is all done through the corporate logins. Any large enterprise today would use one of the big solutions like Android, Microsoft Android ID, or Okta, or any of the big providers. So this is all follows enterprise security policies, multi-factor authentication, and so on. It's all federated access. So it takes that manageability of the access away from the people that actually use it. It puts it in the realm of security and compliance teams, and access that is inherited and federated based on the role of the team, the person that needs to get that access. In the same time, we isolate the access. So down below, there's two, for example, there's a prod and a non-prod account. The access is given to either type of account based on the role. There is a resource access type. So if someone gets access, the policies behind this access in the cloud are very specific to applications and resources that the team, the person that this role belongs to has to access. So again, following the least privilege type of access principle. In this particular example, our egress shows we have a hub and spoke architecture, just like similar somewhat with the on-prem, except that this egress now is to the internet. In this scenario, we have a centralized egress filtering VPC, is what we call a virtual private cloud in Amazon. This is essentially a logical data center, a subset of the data center. We've deployed security appliances, and then we have traffic inspected on its way out to the internet, and allow that only based on specific policies are met.
I'm not sure if this is a network architecture question, but I'm curious whether you're utilizing Amazon services for, excuse me, transcoding, other processing, frame rate conversions, that type of stuff, and if you are, how you're metering that in order to plan your budgets and processing and all that.
We don't use directly, so we use Media Convert.
Yep.
Which is part of the. So we use Elemental Suite, a few services from the Elemental Suite, but Media Convert jobs are triggered through external workflows from one of our vendors. So not directly. Now, when they get triggered, those objects, those jobs get tagged, and they belong to since they belong to our account, they will be falling under our reporting and FinOps tracking.
Yeah. Can you hear me, Claudio?
Yeah.
Okay, perfect. So we do, like Claudio mentioned, we do use Media Live, Media Convert. So for our master control, actually, right now for our cloud master control, so all the discovery channels, we leave the Imagine environment as, I believe, RTP, and it goes into Media Live, and Media Live does the transcoding. We try to lower costs to do commitments, so 1 year, 2 year, 3 year commitments. In terms of how we calculate the costs, I don't know, Brett. So for our transcoding, so the Media Convert, we use a company called STVI to do the orchestration. So Discovery, Warner Brothers will send us content. STVI will move the content around, process it, and it actually enables the Media Convert jobs. And we tag them appropriately. So because we're multi-tenant, there's banks on the AWS account, cable, wireless, everything is on the same account. But I guess that's a management question of like. I think the big thing for us with moving to the cloud was speed, right? Because we got the Warner Brothers deal so quickly. It was really the only way. Do I have that? Is that right, Brett? Yeah. So, but some of the applications that we've developed, we've started dabbling on actually building our own transcoder, scalable transcoders using FFmpeg. So. There's some cost savings that we could do there as we experiment with Kubernetes and FFmpeg. So, but yeah, but we're not saying that cloud is the cheapest, but it is fast and it is reliable. Hopefully that answers the question.
One more over here.
Okay. Hey, Nick.
Hey. Virtualization.
Yep.
So everyone knows the issues the industry's faced with one of the vendors. The prime one is squeezing everybody. So I think everyone is experimenting with different platforms, whether it's Proxmox or OpenShift or the other ones. Would you say that, if you were to put into ratios, what percentage of your infra would you say is traditional virtualized VMs versus containerized Kubernetes? And I guess some of that, since you're treating your cloud as an extension of your on-prem, how much of it is there as well?
So the majority of it is virtual machines on-prem. I don't think you guys don't do any Dockers or Kubernetes, do you? Okay, never mind. So what's the percentage of VMware clusters on-prem and Kubernetes and Docker?
We have approximately 850 VMs on-prem in VMware cluster, and I'd say 1% of that would be Kubernetes Docker.
Yeah.
we operate several clusters. Only one of them is licensed for Tanzu. So all of our Docker containers are run through VMware Tanzu, if anyone is familiar with that platform.
Yep. So the majority of it is like our virtualization is on-prem, but as we move to the cloud, we've seen actually a lot of companies moving towards Kubernetes, right, Claudio? Like so far, what we've deployed is a lot of Kubernetes, right? Like Imagine is Kubernetes based. So yeah, go ahead, Claudio.
Yeah, you're right. Either Kubernetes or containers. We use the Elastic Container Service. So again, managed service, running containers as a managed service, staying away from Docker and staying away from managing Linux machines or Windows machines as much as we can. Yeah, containerization.
And follow up to that, and how painful have you found it vacating from VMware, if you are, to other options?
George?
We've tried everything. We had the Proxmox cluster running for a while. It never made it into production. OpenShift, KVM, Hyper-V. At the end of the day, my opinion again, I don't think it's worth breaking away from the established workflows that we have with VMware and the long-lasting relationship we've had with the VMware product line to save a few dollars. I'm perfectly comfortable putting my name against the VMware banner and going down with that ship if it means I have to.
Thank you.
Probably just leave this here.
Can you speak a bit more on how you budget and track costs on the cloud? So do you have certain tools that you use, or do you go by a budgeting model by forecasting what is required?
Yeah, the majority, so like for our master control, I think we do reserve instances, right? So every year we basically commit a year of EC. Maybe Claudia, you could talk about what our commitments are usually for at least the Imagine environment.
Yeah, we try to take advantage of reserve instances and compute savings plans where these exist. So in EC2, for EC2, MediaLive databases, where those can be obtained for a year up to 3 years, even with no upfront costs. And those could mean significant savings. Again, no upfront costs. And these things in some cases, can be capitalized as well. And as far as tracking, we leverage a few tools. One of them is something from IBM called formerly called Apptio, I think. I don't work on FinOps, but when we build estimates, we usually start off with the Amazon price calculator, which is the highest cost in US dollars with no discounts and so nothing that your MSA probably would include, because in your MSA you could get a discount, like a blanket discount for certain things too. So that is a start, and then that process follows from there. So we go through the approvals and then the estimates and so on. And like we said earlier, when we can take advantage of these things, we will through both compute savings plans and reserved instances. And these are usually put in the organizational level, so the entire organization can leverage them, and they get applied against the bill. So it's not something you buy that applies to a particular appliance. So for example, in this picture, you're not getting a reserved instance to cover appliance A here. You're going to get an appliance reserved instance that covers an instance type. And then Amazon, at every end of the month, they apply the discounts they want to have against what you've consumed. And then that's how they reconcile the whole thing. I hope that answers, or at least provides some insight.
Thank you.
And Brett, do we pay OpEx or CapEx? Do we capitalize? I don't remember now. OpEx, yeah. So that's a secret that our VP would have to talk to you about. I don't know how he sold the business on cloud, but it wasn't easy, right? Like it was years really of trying to convince them that this is the right path to take. And again, the Warner Brothers thing was just like, yep, we got to do this. So I think Pierre was very happy about that, and obviously our AWS rep was very happy about that.
Have you ever had to move something back? Oh, do you want to go?
I was going to add one more thing, which I realized is really about it. A lot of the vendors, a lot of partners that we deal with, they're already in the cloud. So when we talk about sending data back and forth or integrating with their software or their SaaS software, if being in the cloud is a huge advantage because we exclude a lot of the problems that we'd otherwise have to solve through building in-house. So there's private networks you can build in the cloud between us and our vendors that deal with accessing APIs that we need from them or ingest the data from them, or Warner sending us data, for example. It's a lot of the problems are solved by the cloud itself, because if we use S3 as a shared bucket, for example, and we do it securely.
Yeah, and also like Warner Brothers was in the cloud too, so doing an S3 to S3 transfer I think was cost efficient for them too. And like one thing I do want to bring up again is the cost that we pay for egress. It's 1/5 cheaper to egress back to our direct connects than it is to go through the internet. So it's massive saving. So just think about it from perspective of SRT video, right? So instead of going to sending your SRT 4 times over to the same destination, we bring it back on-prem and do the SRT distribution on-prem, because it's so much cheaper to leave it on-prem on our internet than it is to leave it in from AWS perspective. So 1/5 the cost. So we try to utilize our on-prem network as much as we can, right? So we get it's really the best of both worlds, being a hybrid environment.
Okay, so have you ever moved something from SDI to the cloud or 2110 and had to move back? And is there a way to go back? Like, will the vendors even sell you SDI anymore? I ask this because, like, you see what AI is doing, like data centers.
Exactly.
Everything's becoming a lot more expensive from consumer into, data centers. So
I think vendors will sell us whatever they can to make money. But yeah, I think the biggest thing is that you kind of hit the nail on the head there is we haven't even, like, us having all the content in object storage, we haven't even, touched what the possibility is with that. Around metadata tagging and video processing through AI. Like, there's so many things we could do. And I think we have like 3 projects lined up around AI and video analysis right now. So I know that didn't really answer your question, but no, we haven't had to move anything back. Yeah.
Because you did mention that you guys moved from Azure to AWS, right?
That was our, because that was our streaming partner. I think their preference was AWS. Yeah. So that was Delta Tray. They're like, do AWS. So, but it wasn't a move. It wasn't like Azure wasn't satisfying our needs, and it was a joint, I guess, collaboration on what makes sense from their perspective and what they saw the market as, right? The market still, like, AWS is video, right? So, I mean, Azure removing their what's it called, the Azure Media Services, I think really hurt their reputation from the video perspective. So everyone kind of abandoned ship on that. Yeah.
Adrian, would you agree that being in the cloud with your compute and your content can potentially and likely give you an enormous advantage for new applications like AI that can run in the cloud? So you have access to all your content, to learn all your content. And
absolutely. I don't think I say too much.
All right. So I'm asking dangerous.
Okay, I'm not going to say anything. But I will be at NAB talking about one of our applications with Microsoft. So if you guys are there, you want to sign up for the seminar, I'll be talking a little bit more about that. But honestly, there's so many. We had, again, not talking too much because I see Brett is already pissed off at me, is one thing that the Jays came to me, and I haven't even told you yet, is like they get all their archive for the game. So they have, like, it's not the production team, it's like the, I'm not sure what you call them, but it's the team that does like short clips, right, in the stadium of fans and players. It's not the broadcast crew, but it's like the shooters, I guess you call them, right? They have no way of doing any metadata. So they, all these camera people and photographers have all these things, and there's no way for them to organize it. They literally put in a OneDrive. So they're asking us, with some of the technology that we've already built to help search their database, which is a OneDrive for, like, Vladdy clips, right? So there's so much things you could do with it, and like I said, getting it in the cloud is the first, and then you could do so much cool things, right? But it's the storytelling of telling the business why it makes sense is the difficult part. Technology is easy. It's business that's difficult.
Yeah.
Right? And money.
Yeah, for sure. Thank you.
Okay. Thank you, Claudio. Thank you for joining us from Calgary. Hopefully it's nicer.
Pleasure.
Yeah. Okay. So now we talked about kind of our team evolution. We talked about, I gotta switch this. We talked about team evolution. We talked about how we utilize our on-prem network with our cloud environment. We're going to switch gears a little bit, and I'm going to talk about observability, and then we'll finish it off with software. So thank you again, Claudio. How did observability come into play here? We fully relied on vendors to do observability. So I'll switch over to this slide. So, we use VL Pro heavily, but what if everything didn't terminate into everts anymore? What do we do? So our first... Oh, man. So the big thing is, like, this is a hybrid environment now, and it's not a single vendor solution. So how do we build a monitoring stack to support everything? It's very difficult to not have a single pane of glass. So this was the first use case that we had where we we built our first express routes, and then we had no metrics on how we know what's performing. So we had a mixture of hardware. So we had everts ITXE. We use that for all our encoding for Azure. We have Telestream Inspector, which does TR101. We had everts NAT cards. We had Haivision gateways. We had, where we still do have, Cisco CE switches. We had our fiber. Typically, when we built 10 gig fiber, it would go into everts, and everts would do the monitoring for us. So what happens when it's no longer everts, right? So we had to come up with a solution. And I guess I'll go back to my notes. So this was our first problem. Sorry, kind of went off script there. We went to procurement first, and it's like, what do we do here? How do we visualize that? And they said, well, we have Splunk, we have New Relic, and Datadog. Pick the one you want. We took a look at their prices, and we're not doing that. So our observability journey actually started with open source. So we pick two products: Grafana as our visualization, and Zabbix as our backend. And the reason why we did that is Zabbix has a really nice, easy to use way to bring in SNMP traps and APIs, and build drivers for products that don't have drivers. Like broadcast is very specialty, so Zabbix is not going to have, you know, a Evertz NAT card or a Haivision gateway. So we collected information from all these things. So if I remember, the ITXEs were API, Inspector was an API, NAT card was API, SRT gateway was API, our Cisco switches were SNMP, and Azure, Grafana does have a native Azure Monitor app, so we're able to pull those metrics in directly. So it's kind of this is the solution that, you know, or this is the problem that we had that kind of started our observability journey. So what does it look like today? Wow, that's really small. Sorry about that, but I'll kind of explain what we've done here. So that was our first problem. We built it out a lot over the last 2 years. So instead of open source Grafana, we actually moved to Grafana Enterprise. Instead of open source Zabbix, we also moved to Zabbix Enterprise. With our Grafana Enterprise, we have Prometheus and Loki collectors in the cloud, which does Prometheus, OTel, which I'll have a couple slides on that. But this architecture supports on-prem and in cloud. So I guess starting with the middle where you kind of could see the Grafana, that runs on-prem. It runs on a virtual machine provided by George's team. We have LDAP that goes directly into it. And again, even though there are some things that are in the cloud, everything is, you can only access it through Citrus VPN, which is on-prem, and then it goes up our direct connects. So we have Grafana Enterprise Server on-prem, runs Postgres. We originally ran NoSQL, and that was a disaster, so it's just too slow for what we were doing, so we upgraded to Postgres. Grafana is amazing because it has every data source you could ever think of. It's basically, I think the term that people use is single pane of glass. It really is a single pane of glass, but it's not single data source. We have many, many data sources. So on the app side, we use New Relic. On multiple vendors like Vitaspine uses Elasticstack, so we're able to open up their Elasticstack. InfluxDB, a couple vendors use that. Zabbix is one of them. So it really is a nice aggregator to everything. I do have a demo that I'll show. But I guess this slide shows that on-prem and in cloud, we have these things called Alloy. They're collectors for Prometheus and Loki for logs and metrics. And we have for Prometheus or Zabbix, it's on-prem and in cloud. So if there's a driver that we need to create, we could do that in Zabbix in cloud. And if there's something on-prem, we could do that on-prem. So there's proxies for in cloud and on-prem. We also can support vendors sending us logs via RFC logs, right? So we aggregate port 1514 and 514, I think. I can't even read it, it's so small. But if a vendor like Evertz does this a lot, where you could stream through UDP, we accept it through there, and it ships up to the cloud. So I guess the main thing here is this observability stack is cloud and on-prem. And of course, a big one is, which I don't even see. Oh yeah, it is right there. It's we also have CloudWatch. So everything that goes into CloudWatch, we could build dashboards on that. This is the document that we send to our when we do any RFI, RFPs. This is kind of like our starting point of if you want to be in our environment, this is what we need. This is what we need from vendors. So Yes, from a logs perspective, the formats we accept is 316 RFC 3164, which is a legacy syslog, and then RFC 5424, which is structured, so it has like warning, error, different levels. We could accept them via streaming, so through a UDP port, or we also hoping that people will get on the OTEL train, which I'll talk about in a second, to put these collectors to collect metrics and logs. Metrics, we accept Prometheus or OTEL data, so we could send it up to the cloud, or like worst comes to worst, if a vendor does not have OTEL or Prometheus, what we could do is we can create our own drivers. So again, through API calls, SNMP traps, Zabbix is very good at being able to create that. So I'm gonna just do a quick example here, and then we'll jump over to a demo. But this is our Warner Brothers stack. This is really showcasing how a single pane of glass is very easy for operations to troubleshoot issues. So we have a couple things in our stack. It's not everything, but this is basically everything from the output of master control in the cloud to the distribution of it. So it's the live video. We can pull the media live logs, which are logs and metrics through CloudWatch. We can pull we have eVerts multi-viewers, MVIPs in the cloud, so we could pull the metrics via an SNMP through a custom Zabbix driver. We have, that's Imagine logo, so we have the Aviator, we have logs and metrics that go into Prometheus stack. Appear also supports logs and metrics through Prometheus. And then we also have Haivision gateways for distribution of SRT distribution in the cloud. And again, that's also through API calls with custom drivers that we built. But it really funnels into a single dashboard, which makes it really, really easy to troubleshoot. So I will showcase that. I remember how to do this. I go like this. Uh-oh. No. 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 Come on. Yeah. Oh, okay. Got it. Got it. Okay. I don't do live demos. Okay. Ah, come on. The kill. Oh yeah, you're right. Yeah. There you go. Oh my God. Click what? Yeah. Yeah. Yeah, click it. That's what I'm doing. Yeah. Yeah. Click on Grafana page. Yeah. Oh. Okay. Yeah, this is my. There we go. Okay. Okay. So that dashboard that we were showcasing, I will showcase that. Okay, so this is overall dashboard of the system that we have in place. So our 24/7, this is, I believe, up on our 24/7 NOC. So they wanted something that's very simple, green, red lights, to know when there's problems, to do a bigger, a deeper dive. And we're able to pick our channel here and kind of do a deep dive on more than just high level. So this is a high level tab, but then here you could see all the different things that we've collected. So imagine we could pull all the logs, and that's just based on discovery. So we could switch to discovery ID. So this is showing the RTP feed leaving the environment. Then we have what's next is our multi-viewer. So the eVert multi-viewer has a TR101, so we're able to pull basic metrics on that. And also program bitrate. So leaving our VPC, we're able to see that. Then we also have our HeyVision gateway. So we take a single feed in, our RTP feed from Imagine, and then we distribute it to a bunch of different partners. So we send it to Amazon Prime, we send it to Delta Tray, which is a streaming partner. We're able to know everything that's happening from that perspective, and we're able to see media live. So we do an upconvert in media in our environment. So 1080i to 1080p through media live. So we're able to see at that point, make sure it's good, make sure there's no drop frames. And then we also have a peer unit on-prem. So I wanted to show this because this is a single dashboard from multiple data sources. So if I go into here, so media live, for example, this is very laggy. This will show that this is coming from CloudWatch, right? If I go into something else, it was showing from Zabbix. So it looks like it's a single data source, but it's really not. It's mixtures of data, but it's in a single pane of glass. So imagine what we would have to do to troubleshoot a single problem. You have to go into Media Live, log into CloudWatch. You have to go into a peer, check for the logs. You have to go into the multi-viewer and see if it's okay. You have to, go into the Imagine logs and make sure master control is good. This is just a very quick way that we could troubleshoot issues, and that's because of observability. Okay, hopefully this doesn't take 10 minutes. Switching back. Okay, there we go. I got it, yeah. Bam. Okay, we're back. Yeah, so that was basically all the data there. What the role of SRE? So Mike is here. He's our only SRE, but there's a couple things that I guess the term SRE is defined as a software engineer approach to IT operations and uses automation and coding to ensure systems are reliable, scalable, and efficient. And then you've heard me use the term observability. Some people have never heard that term. It's just like the act of monitoring. So the ability to understand a system's internal state by analyzing its external output, specific logs, metrics, and traces, allowing teams to debug complex unknown issues in real time. So the first step, of course, we have to collect the logs, but the SRE's job isn't done there. One tool that we have is obviously dashboards. Dashboards are nice, but alerts is better sometimes. So we have Teams alerts or email alerts that we send after things reach a threshold. So if a bit rate goes from 20 to 15, we have a alert that it triggers. This takes a little bit of patience. I know some of our engineering teams like too many alerts. So it's not something that you set and forget. You adjust it to meet the business needs and what's required from the business. Sometimes it takes a couple times to tweak it to make sure when you're getting an alert that it's something that's imperative and not just something that is a nice to know. And then the last part to this is because we have a process manager, we're able to build databases where engineers can go to a page and understand what that means. Like, so if we have an alert that goes off, at least there's understanding of what the threshold is, why it was broken, and how to fix it. Okay. So I want to talk a little bit of OTel just because we do have some vendors here. And it's something that makes our lives easier, so I'm going to take this opportunity. So OTel is a unified standard for collecting and analyzing metrics. So we have infrastructure on the left, and then that sends things to metrics and logs. Typically, if you have some of the big observability stack companies like Datadog and New Relic, Splunk, you have a proprietary agent, and that collects the data, formats it into their standard, and then you put it in Oli backend. So Oli is short for observability. And then your front end queries it, right? So I had the example of we have a front end, which is Grafana, but we have multiple backends, right? We have multiple data sources that we can query. What OpenTelemetry does is it standardizes that proprietary agent, standardized in a way where you could send it to any provider, so Dynatrace, New Relic, Datadog. It's a way of standardization because if you haven't been in the observability space, the companies like Splunk, like Datadog, they make millions and millions of dollars off of observability because they kind of lock them into proprietary agents and your data is kind of stuck. And a lot of people then find out that their observability bill is actually more than their AWS bill. It's a very common issue, right? So OTel solves that issue by standardization. Kind of like USB-C, right? Standardized, I think a lot of it was forced by the European Union, but yeah, everyone, think of OTel as a USB and the plug being different softwares. It's a standardization, and that cable, although it's not the most expensive thing, that cable can be used for an Apple, it can be used for a Samsung, it can be used for anything, hair dryer, whatever you need. A little stat here. So by 2026, OTel has become the default way organizations instrument modern systems due to its flexibility, and biggest thing is cost savings. So quickly go over this is there's two collectors that vendors can use. There's OTel, there's an OTel collector, or there's Grafana Alloy. Both support OTel, but I would encourage vendors to help the community by deploying this. It helps us from creating drivers, of course, like we mentioned, figuring out SNMP traps and APIs. A lot of vendors have moved to this, but not all of them. So, my encouragement is to look into it. It supports everything: Linux, Windows, Mac, Unix, different deployment environments, Kubernetes, Docker, bare metal, and then configuration tools like Ansible, Chef, and Puppet. It can be deployed to anything. So that is my ask. Please look into this. I will give a shout out to some vendors that do Prometheus or OTel right now. Peer, Atem, Imagine, and Vitaspine. Makes our lives easier. Please look into it. Yeah, I'll leave it right there for any questions around observability.
I have a question about Grafana.
Yes.
When are you going to move it off my cluster and into the cloud?
That's a very good question. I hate this guy gets the best laughs. He gets the best laughs. He doesn't even want to do this. What can I say? So the biggest thing right now is procurement and getting Grafana certified with Cyberstar, and then getting an application ID for it, and then never. And that's why we use two. We use we have Grafana on-prem, so we could access LDAP, and then we have it in the cloud to do our data collection. But yeah, that's a better answer. Hopefully never.
Adrian, you said you moved to the enterprise version of Grafana.
Yes.
Is that for my understanding is there's increased security in the enterprise versions. Was that why?
No, there's a scaling thing. I think the biggest thing why we moved to Grafana Enterprise was Prometheus scaling. They do that all for you. So
Okay.
eventually you will run, if you have a Prometheus server, how do you monitor the health of it? And if it's overloaded, you have to now do clustering. Like it's been a problem with Prometheus, which is why Grafana built something called Mimir, which does scaling Prometheus servers. So we don't have, again, similar to AWS, like we don't have DB admins, right? So we love RDS because it does it for us, right? It does the scaling for us and optimization. It's the same thing for this. We don't want to worry about load balancing multiple Prometheus servers, and the industry is really pushing towards OTel, so it's just a lot easier for us. And logs too, right? Logs, massive amount of logs. We use something on the Grafana side called Loki, so it also does scaling for that.
Okay, thank you. There was also a question in the Q&A about C2PA, content provenance and verification. Do you use that on your content?
No, I'm not sure what that is.
Okay.
Is that for privacy? Like
it's for validation of the source of content.
Oh.
Yeah.
I don't think.
News applications often will use it.
So really, for the observability stack, it's mostly on the machine level. So machine data, making sure the health of the system is okay. But no, we don't have. I'm actually not even sure what that is. So I'm not going to pretend to know what that is.
Yeah. Yeah.
But yeah, mostly we're collecting machine data. So no PII information, nothing like that, right? Okay. That's on the corporate side.
Okay. Thank you.
Okay. Bear with me. I'm going to try to finish. We got 0 time. Sorry about that. 10 minutes. Okay. So the last thing that we'll talk about is software development. I guess from a software perspective, it's easy to see the cost of how much developers cost and how much this team costs to run, but the big 3 things on when we decide to either go to a vendor to buy software or do it ourselves. Obviously, is a calculation based on our costs, but also we don't build software unless it improves these 3 things, right? So it has to generate revenue, it has to reduce our costs, versus going to a vendor or getting a vendor to write the code for us, or it has to help with operational efficiency, right? So make money, spend less money, and the same people can do more now. So that's our criteria for building software. Some of them hit multiple things, which is even a better use case for us to do storytelling on why this is important, right? To next question, what our platform stack is. So we use Azure DevOps for our CI/CD pipeline, and I'll go through this quickly because we're running out of time. We have Jira for our ticketing system. We have some Java applications. We're shutting them down really to move everything to JavaScript because we don't have 40 people logged in. We build tools for operations. Running in JavaScript is nice and quick. So we run a JavaScript Node.js or Next.js. Databases, we do Postgres or CouchDB for non-SQL, but we've been trying to move as many things as we can to RDS because we do not have database admins, or DocumentDB in cloud. It's really a good use case for cloud is databases. We have we use multi-cloud. So for AWS is pretty much everything is on AWS, except for AI services. We use Microsoft pretty heavily for our AI applications. Our front end is React, and it's all built on Material UI. And then we talked about our observability stack. Okay, some applications that we've built. So we have built quite a bit of applications, middleware and apps. So I'll start with the middleware. One of our big things that we do is just which a lot of news organization does, is just bring in data, right? So data from Sport Radar, Bet99, Bet Rivers, BetMGM, matching it to games. It's a big part. It's big revenue, obviously, is betting. So bringing that data in, we build middleware between our MAMs and STVI, Mediagenics. To move, one portion might be doing sales, the other portion is doing programming. So now how do you bring that together? This is actually a lot of the stuff that we do is middleware. And it's not the most fun, but it's imperative to the business, right? It's core functions for the business. And then we've built, quite a bit of apps over the last 4 years. We created an app called AdCert. So that one I'll quickly jump and just do run it over on how we built it, showing multi-vendors and how we use APIs. We've built schedulers. We've built our VOD app application. We've tried to rebuild our something called Autopilot, which many of you might use, but it hasn't been a priority, so it's kind of on pause. And some AI applications that we're really excited about. Like I said, we'll be talking about it at NAB. One of them is around descriptive video. We're able to build descriptive video through our applications with AI. And then we have a bunch more experimentation. We have another project that's around AI that's underway now. And we have 2 more, one with the NHL, and one with MLB, the one I mentioned around content, just for experimentation. My thing is experiment as much as you can. So let's quickly talk about the AdCert application. So when we first got all the content for NHL, we didn't have enough master controls to kind of play everything out. Because some nights there could be 8 games, 10 games from an NHL. But we wanted to still get the ad revenue on that. So we built an application that it does manual ad insertion. We have these pods, and it controls many things. So this is a high level of what it does. It's based on React and Node. And it talks to a bunch of APIs from different vendors. It does routing in the Evertz environment through something called IRM and adding some routing to the Scorpion platform. It pulls metrics from Telestream, so we know that the SCUDdy message happened. It does the SCUDdy insertion on our elemental encoder, so we're doing time signal-based SCUDdy insertion. We add UPIDs to that with data to our ad servers. And then, of course, we have our monitoring stack that we push everything to make sure everything is working as it should. So this is just one of our product, and this is a good showcase of it's not software-based, but it's hardware-based, how APIs and how you could build applications with just tools from hardware from multi vendors. One thing, I think these are reversed, but one thing I quickly want to just talk to our wonderful vendors is from a software perspective, a lot of people do software as a service, but my hope is more people will move to platform as a service to offer things via API, so switching or multiview through an API. I believe we're at the tip of the spear from a software-defined broadcast perspective, but I would encourage people to look at their stacks and kind of not sell the complete picture, but services, media services from their stack, which can help us build tools, right? Like I think the future of software is building things together and not in isolation. So broadcasters and vendors working together to build some interesting things. Why it kind of makes sense from a vendor's perspective is if a vendor does SaaS, right, the vendor has to build every single feature, slow integrations. It costs them a lot, obviously, to get that finished product, limited customization, and complex ecosystems. If a vendor has a fast channel, but if they could just sell us the switching services or, you know, the SRT outputs. Sometimes it's easier for us to integrate into our ecosystems. You know, vendors can't plan for everything. They can't plan for every single MAM system, every data source, every storage, every AI tool, right? Like more and more we move into software, the more we're going to require a toolkit versus a complete product. So yeah, my messaging would be for broadcasters to start, you know, doing experimentation, start building their own things, building their own software. I think we have so much knowledge in the broadcast space that you know, with the right software teams, you could create some really interesting things. And you know, my message to broadcast or to vendors is, let's co-create things. Let's not work in isolation. Let's work together to build things. One of some cool things that we're working on. So we built a application based on Node to build descriptive video. We'll be talking about a NAB. It uses a couple things from the Azure AI Foundry. We use GPT-4o. We use face detection. We use Hugging Face for their machine learning modules, and we use text-to-speech. So I won't go too much on that, but yeah, if you guys are interested, I'll be talking at the Microsoft, not booth, but I think they call it the theater. And we've been also experimenting with Matrox. They have an amazing catalog of media services to build, you know, your own software. So media services to do switching, media services to do multi-viewer, SRT, DI. You could really build some, like I said, some really interesting things. And what's great about, you know, both these use cases is having a MAM or orchestration layer like STVI that knows where your data is in the cloud. They know the timing information. They know, you know, what episode it is. It's searchable, so you could build some interesting things. Probably I'll finish off on here because I know I'm way over time. Lessons we learned. You know, building this dev team is, as technologists, I think we all have to do better with storytelling. I think the business really, you know, in this new technology world, like, I think they're kind of lost, right, on what's possible, what's not possible. So as technologists, I think we have to do more to build products to help generate revenue. Experimentation is another one. You know, from my development, for my developers, I leave 20% of their work for experimentation. We usually build a small MVP, then we go to Brett and Pierre, and it's like, hey, we built this. Like, what do you think of this? Is there something that we could use, right? So little, quick, small projects, and you know, sometimes small ideas can become big ideas. One thing I will encourage is lunch and learns too. You know, these are a lot of new skills that we brought into, so we try to share our knowledge. So we do lunch and learns with some of our engineering teams and our operations team. Like we did I think a 4-part Linux training session. Hopefully do some more observability. So, you know, building our knowledge together, because at the end of the day, we have to work together, and you know, we have to support this together, right? And process, and just don't forget about process, and deploying something, and making sure that operations is aware, they know what they're doing. So we try to do that a lot. Is, again, before we launch anything in the cloud, we usually take an hour or two to go through any alerts that the team needs to watch out, to go high level on the infrastructure. Yeah, we try to just work as a team to accomplish goals together. So and more, but I think I'll stop there. I think everyone's tired, everyone wants a beer. So
thank you, Adrian. I have a final question while you switch the computers here. So Roy is going to present us, guide us a couple of slides here to wrap up.
I'll be fast.
So my question is first, thank you so much, Adrian and Rogers, Adrian, Aaron, Claudio, and George for the special participation. Thank you for having us here. And my question is, fantastic. Thank you for the walkthrough from the foundation, the hardware, how the systems, how the infrastructure work, how the DevOps work, and how you build these amazing solutions for the whole team to be here. It's really a fantastic accomplishment. My question would be, a lot of the solutions, the infrastructure, etc., were tailored for Rogers Sports and Media, right? It's based on the corporate agreements you have with AWS, etc., and the team that you were able to put together. And I love the last slide that you did the lessons learning. How you would advise other companies that, of course, are not Rogers, right? They will face different business models, contracts, skills, etc. What do you think would be the advice for them moving forward?
I mean, Rogers is not perfect. We have our own problems, but again, I think the big thing from a technology standpoint is storytelling, right? Trying to tell the story. I think it's easy for technologists to know about, how to fix the problem. Oh, this technology is really cool, and we should move forward with this technology. But again, to my 3 points is like, well, how does it drive revenue? How does it actually help the business grow, right? Like, I think we have to start looking at it from that perspective. It's not just like, okay, let's move to SDVI to 2110 because, it's going to give us X amount of efficiency, right? I think the solutions that we have to put in place, at least from our perspective, need to make money. I think that's because you have to take a look at what it costs, to build tools to support them, right? It has to make, we have to make it worth their while, right? So I encourage just storytelling, build presentations to your managers, and don't use any technology talk. Just how is it going to make money? How is it going to make things better for us, right? So,
thank you.
Good answer. All right. I sense the desire for me to do this quickly. I will. So please consider becoming a member or a friend of SMPTE. Some updates. There aren't a lot of Canadians going to NAB this year, so we're going to attempt. We did it in January. We did what we call a solution showcase. After NAB this year, we're going to try to bring NAB to everyone here. We're going to probably do an in-person event and a virtual event, so we can have local vendors and then vendors in Europe and across the US. So it'll be focused on what the vendors introduced at NAB. So give you a great overview without having to fly to Vegas and walk around for days and days. And the boot camp. More on that. May 21st, we're doing our boot camp, which is focused on sports. Live production and the fan experience. And it's focused on sports, about technology. It's going to be, whoa, just about broke Silvino's computer. It's going to be great. Okay, thanks. But I want to emphasize as well, for anyone that doesn't work in sports, the technology still translates. It's just fascinating technology for live production. These are just some of the presentations we have lined up, and we're working on more. A couple of stars. Dwayne is here from MLSE, and Mike Johnson from Dome. We're going to do a panel with Mike Johnson and Mary Ellen from Dome, a panel with MLSE, Scotiabank, and Dwayne and Mike Christensen from Rogers Center. So we have CBC going to present on DMF and MXL, what they did at the Olympics. TGI Sport on virtual advertising. Giraffic on AR, VR. Ross Boramy is going to present on aerial cable systems. Evertz, Lavo, and more. Also, AWS, NOR is going to present on cloud-based live production. So everything relevant is going to be fascinating discussions and presentations. Please come. Please come. May 21st. Okay. Tony, you're on. Thank you, everyone. And before I give up the mic, I'll just say thanks again to Adrian and your whole team for sharing so much. It was fascinating. And I think amazing what you're accomplishing with just a small team, and how I think about just thousands of Rogers employees are being touched by what you develop. So really, really great stuff, and great messages to the industry as well. Thank you.
Thanks, Roy. I just want to take a couple minutes to recognize Brian. That's for later. He's retiring. So a couple of things, just, Brian, so you know, I've got a lot of friends around me that have retired lately, a couple of years ago, many years ago. And the common thread is every time I ask them what they did, they'll say, I cut the grass. And then there's a pause, and I'm going like, well, what else did you do? I cut the grass. Yesterday or the day before, I'm trying to hook up with a friend of mine to do a lunch. Can't do Tuesday. I'm getting my hair cut. So yes, just keep in mind that you can slow down, but don't be a one event day guy. So I took this from LinkedIn, because I just looked at your rap sheet and said, hey, you know, this is interesting, because I see a lot of 6 degrees of separation here because of all of the companies that he worked for. So 2 terms at SAIT, one for technology, architectural technology, broadcast technology, 80 and 84 respectively. ASCAR, that's Steve Pumple, right? It was. ADCOM. Electronics, Peter McDonald, Gary McEwen, Michael Martin, Mind's Eye Technology. I'm not. Gotcha. Okay. CTV, Big Blue. Were you on the mobile? That was 13 years. Hughes, integration. That's Bruce Long. Yeah. And then 2014 to now, he's Rogers Sportsnet, Senior Manager Engineering and Senior Manager Distribution Engineering. So Brian, we thank you from SMPTE and everybody in this room that for all of your work that you've done in the community and helping SMPTE and things of that nature. So we thank you. So I have a recognition of certificate of recognition. So we thank you.
Thank you very much.
Cool. And before I give the mic up, I know I turned the screws on Zoom last night and kind of gave everybody a lot of hurt. So it's one of those things that it kind of said, you shouldn't do that, and all of a sudden, oh, you shouldn't have done that. So anyway, just to get back in your good books, there's a bunch of these outside. You can fill them up with food, because there's still a bit of food left. So this is just my way of buying some goodwill. And some technology things tonight. From Calgary was Claudia. We was on Teams. And we're feeding out Zoom. So it's kind of cool. Anyway.
Thank you, everybody. Our network is social, Bishop and Belcher, for one who wants to pay a beer to our retirement guy. So hope to see you there. Thank you so much for coming, and I hope you have enjoyed the evening. Thank you. Bye-bye.